Okay. Hi, good morning and welcome. My name is Larissa Overbey. I'm a technical marketing engineer with the Enterprise Switching and Wireless Group. I've been with Cisco for 17 years, transferred from security, operations, network management to where I am today. I'm going to be talking about how you can simplify deploying firewalls with SD access. And you guys have all heard about SD access, correct? Mm-hmm. Is there anyone in the room who has not heard about SD access?
I think a 30-second high-level overview
Cool.
is still worthwhile.
Awesome.
Yep.
Then this will just be a quick refresher. You guys know what we've deployed, what we've released last year. We have identity-based segmentation. This is group-based policies, segmentations around utilizing VRFs. We're able to automate this through the DNA center that you guys just saw with the GUI. And we're able to get 360-degree views on how the network is doing, how the endpoints are doing, how the clients are doing. We have our underlay, which is basically our physical devices. SD access can be deployed on existing infrastructure. And then we have our overlay, which is utilizing that control plane, Lisp, and utilizing VXLAN to do our data encapsulation. And then we have TrustSec as our policy plane. So the components here, you guys all know, but I want to point out here, the firewalls are sitting outside of the fabric. Okay, we have our DNA center where we're doing all the automation. We're able to see all this visibility on how the network's doing. We have our identity services that is responsible for identifying who and what is on the network. And it's responsible for giving the authorization correctly. It's also going to be pushing all of the TrustSec tags and the TrustSec policy. We have our control plane nodes, which are responsible for mapping all of our endpoints on the network. Our fabric borders, which is our entry and exit point to our fabric domain to another layer 3 domain that's known or another layer 3 domain that's unknown. Fabric edge nodes, those are our access points, along with our WLC, where all the endpoints connect to. Okay, so today, we have a lot of different firewalls. This is a bit extreme, but I'm sure you'll get the idea. For us to have stateful inspection, we have to implement firewalls in different locations. They may be in between in front of our data center. They may be in between two different campuses. They may be in between two different layer 3 domains, two different fabric domains, etc. What this means is we have all these different firewalls that we have to manage, right? We have all these different firewalls that we have to monitor. We have to implement all these different policies, which means we need to understand all these different subnets, all of these different attributes. It's a lot of work, and there may be different types of firewalls. You may have to manage different types of OSs, right? And you may have a lot of different performance issues or other issues. It's just a lot more firewalls to have to manage. So with SD access, because we're doing our segmentation with VRFs, virtual routing and forwarding instances, we're able to continue that segmentation while still doing stateful inspection through the firewalls. And we don't need to have firewalls at all these different entry and exit points because we have our fabric domain and we have the traffic that's going from or into our fabric domain. It can go through that firewall. So when we're looking at multiple VRFs, we have a couple different options. So we can do inter-VRF like leaking, right? So we have, in this case, a corporate VRF, DNA center, we call it virtual networks. It's a VRF. I'm going to call it virtual networks and VNs, VRFs, you guys get it, right? Mm-hmm. So we have, in this case, two VRFs. We have a corporate VRF and a contractor VRF. Now, we want those two pieces of traffic to communicate with each other. We require access for the corporate VRFs to the contractor VRF. However, we want to have stateful inspection. How do we do that? Just one firewall. That's all. Sure, you can have HSRP, you can have, you can have your own elements of what you require for redundancy, but you only need one firewall. You can do your intra-VRF leaking. You can do that. You can have your border directly connected to your firewall, or you can have a fusion router, but you can do your intra-VRF leaking there. The easiest way to do this is single context. So you just share those VRFs. Now, we also have use cases where you want to continue to segment that traffic, say, and you want to look at that traffic, do your stateful inspection by having that traffic go to another layer 3 domain. So if you guys all know SD access, we have our internal borders and our external borders, right? We have our internal borders, which are borders that are in between our fabric domain and another known IP prefix. This can be our data center, this could be another campus. And then we have our external border, which is represented in orange here. Then that's used for, it's a border in between our fabric domain and an unknown IP prefix, so the internet. So you can also have your traffic that's going to the internet go through this firewall. And again, you can still maintain segmentation by doing multiple contexts, right? Or you can share it if you need to. If you need to share and link those VRFs, you can do that the same with the single context. So how do we do this? As you guys know, control plane, we're utilizing Lisp within the fabric domain. And then we're going to be doing BGP between the border and the firewall, or the border and your fusion router and the firewall. For data plane, VXLAN, as you guys all know, that's being done within the fabric domain. And then we're utilizing VRF Lite between our border and our firewall, and our border and our fusion router. Policy plane, you guys all know, we're utilizing SGTs within our VXLAN, within our encapsulation in the fabric domain. And then we're doing SGT inline tagging between our border and our firewall. Now we're also utilizing SXP, the Security Exchange Protocol. We're utilizing that from ICE. We're obtaining all of those scalable groups from ICE. And then we're managing, if we need to do group-based policy on our firewall, then we're going to be implementing SGFWs, which is basically your ACL on your firewall. Or we can still utilize that VRF, that segmentation, with the multiple contexts. Okay, so I'm going to do a quick demo. Are there any questions before I go to the demo?
You need to be running the ASA in multi-context mode only?
You don't. So if you want to continue having, if you want to maintain that segmentation between your VRFs, then that's how you would do it. But if you do single context, then obviously by nature, those VRFs are going to be leaked. So it's just dependent on how you want your segmentation. Any other questions? I know y'all were talking about font and size. I reduced mine very small, and this is probably too small. Let me increase it a bit. How's that? Better? Too much white space?
Well, I can see design policy.
Too much white space. Yes, too much white space and your fonts are out of balance again. But like the things you want to read isn't the titles; it's the actual stuff that's underneath.
Correct.
And you make it
Correct.
unreadable. But anyway, that's a design thing.
I do too, but that's all right. As long as you can read some of it, right?
Fine, yeah.
I
Okay.
don't like to read anyway. So
It's the fashion at the moment is to make sure that you actually don't put anything on the page, so you just have white space. I'm exaggerating. It's everywhere.
All right, the GUI guys like you. Okay, so as y'all know, this is the home page. And what I'm going to show you is what we're doing with the layer 3 handoff. So what the layer 3 handoff is at our border. So this is our border here. Again, this is our entry and exit point from the fabric domain, right? So we have all of our VRFs within our fabric domain. We need to hand these off, right? So again, this could be to a Fusion router, or this could be to a firewall directly. Or this, you could have a Fusion router and something else on the other side. So what we're doing in DNA Center is we're automating this. So even though if you guys are CLI people, we're doing this. We're doing this for you. What we're automating is the BGP configuration. We're automating configuring the interfaces. So I already have, this is a co-located control plane and border. That means the border functionality and the control plane node, the control plane functionality, both are done with this single device. I've already have this configured, so I'm just going to show you what, how this looks rather than go through and do it. So the border, when you do configure your border, you define if this is going to be an internal or external, right? So this is going to be to prefixes I know, or is this going to be to prefixes I don't know? Example, the internet. So this is an example for rest of company. So I'm going to leak these VRFs out, maintain my segmentation to another domain I know. You define your local AS number. And again, I said we're using VRF Lite. I've also already defined an IP pool that is going to be used to configure all the /30s on the interface of my border. And then you define the interface that's going to be, or interfaces that are directly connected to your Fusion router or your firewall.
May I ask how you communicate with devices, programmatically? Because you said we're not touching the CLI and things like that. So how does the...
how does DNAC push the configuration to the devices? Via SSH.
It's just SSH, right? Okay.
So it is literally doing the CLI for you.
It is.
Okay.
So
So
it
what
has
does
some
that mean?
repository of, version by version of syntax and things like that. And
I'm sorry?
so it has in its repository built in some, semblance of syntax and version.
Based on that config. True.
it would have-
Yeah, it does.
Yeah, which is fine, of course.
But we are using iOS XE. We're standardizing these images across the platform, so there's not a lot of differences.
I'm a little surprised.
However,
Sorry.
that is what it's doing.
Yeah, I was just a little bit surprised to hear that, though that's not a bad thing, simply because I know you're opening up those platforms significantly to other methods to automate and orchestrate programmatically, devices. So, but it still works, and that makes sense. So,
Yeah.
So what's the minimum hardware software requirement to work with DNA?
As far as version, software version,
All of the above, yeah.
16.6.2.
On
16.6.2 on our Catalyst switches, and 15.1. I think y'all saw the version.
I'm just trying to figure out if this is something I want to implement, what kind of hardware do I have to have? How backward compatible is it? Can I use any of the gear that I've already got in the closet? Those kinds of basics.
Sure. A lot of the gear that we have today, a lot of the networking devices that we have out today are supported. So your 3850s, your 3650s, certainly our new Cat 9Ks. We have our Cat 6Ks, our Cat 4Ks, ISR 4400s, ASR 1000s. We have a lot of devices that are being supported today. Now, one thing I'd like to point out is these are edge devices, right? So that's your access layer. This is what our endpoints are connecting to. And this is our control plane border again. So the devices within that, so our distribution layer, our intermediate nodes, those do not need to support SD access. So the reason why these devices and these devices at our perimeters need to support SD access is because they need to understand VXLAN, they need to understand TrustSec, and they need to understand Lisp. So you can have a deployment today that has devices that may not support those, but you can still utilize them in your intermediate. Because all these are doing is IP forwarding. They're not doing any encapsulation.
You could build this on your brownfield.
You can. You
You could
can.
build patches of green and do a progressive rollout over time.
Yeah, you can. I mean, you can do this. You can do everything on brownfield. The thing I would point out, though, is with your control plane and border node, because your control plane node is tracking all those different endpoints.
Yes.
You're going, depending on how many endpoints you have in your network, you're going to end up having.
Yeah.
You want to look at that.
Yeah, the Lisp control nodes need to be big enough to handle the state for the complexity of the overlay that you want
Exactly.
to build. And then your proxy nodes and yeah.
And then borders as well, because so the control plane node doesn't manage any traffic, so there's no traffic going through it. However, in this case, because it's co-located, it's a border node, traffic is going to go through it. So when you're looking at how many borders, where do I place them, what are they going to internal networks, external networks, and how many endpoints are going through that, how much traffic, you want to pay attention to, how many borders should I actually have? What borders should I have? Where should I place them?
Just one quick question to have the whole story. From the border router, we have a connection to the firewall. Is this something that is for you kind of static, or do you also push configurations to the firewall, or the firewall needs to be prepared from a different provisioning system? Or
So today it is manual.
okay.
It is. So firewalls are not currently supported as part of the automation. They're going to be supported for assurance first, and this is in a month or 2 months, I think. So we'll get some assurance, we'll get some visibility into them, but you will have to configure them manually. But however, you do get all this automated configuration on your border. Well, you're really just mimicking that on your firewall, right? Because you're putting the other IP address of /30 for that /30 subnet onto the firewall that's connected to it, right? And you're just swapping the BGP configuration because you're using a different local AS number.
Sure, but would
But
be
it is
nice
manual.
to have the end-to-end, yeah? So you have
It would be,
still one
and it's on a roadmap.
Okay.
So it's going to use like ZTP or something like that to do the configuration, zero-touch provisioning, long-term.
Yeah, that's our plan. Yeah, because we can't have half automation. Right? I mean, it's the automation not only does it save you time, but it saves you having to even know the configuration. So if I'm an admin and I'm configuring this, I'm using DNAC to configure this, I don't need to know how to configure TrustSec and AAA and VRFs and BGP. I trust DNA Center does it, and it does it with Cisco best practice config.
But via the CLI, right? Did I hear that right? That it was doing it-
Yeah, so it,
SSH.
yeah.
Why is that? Why is it going SSH into the CLI? I mean, did I misunderstand that? Is it screen scraping still?
Yeah, that's my understanding.
Why no netconf?
Well, that was why I said I was surprised.
So-
because we
Yeah.
have seen the advent of opening up the OSs, NXOS, iOS XE. You can drop into a Python shell and you can use netconf. All those things are available to you. And generally, I think the industry is considering them better for programmatic network management.
So we do have
Yeah.
that capability.
And people are doing it too, so it's definitely a real thing.
Is that a long-term roadmap that you would move from using CLI
I
to a
don't
more programmatic?
know that is today, but
Probably
it's
should be.
yeah, it is something that we're able to do.
But
As
realistically,
admins,
we
we can
shouldn't
do.
care.
Well,
right? I mean,
You shouldn't.
Right.
That's a fair point.
I sort
Yeah,
of agree
you,
with
you shouldn't.
I sort of agree with you, Larry, because ultimately, if it's all canned
Right.
and automated in this orchestration tool, you're getting the information,
Right.
the from the devices, which is
Exactly.
pure. And so
otherwise, I would build my own.
I can see John doesn't quite agree with me, but
well, it depends. If you only ever use these devices in this context, that's great. However, given a history of very incomplete APIs, be it netconf or otherwise on Cisco devices, the eat your own dog food concept comes up quite strongly for me here, which is the benefit of developing to using one of those interfaces like netconf is that way you make sure it has coverage, because otherwise you screw yourself. If you keep using the CLI, why bother have everything else? Just do everything on CLI. We'll all screen scrape. And I think that's what leads to this situation where we have incomplete APIs in the first place. Yeah, no one ever tried it. The tooling doesn't use it either. So I don't know. Maybe I'm just cynical because I've been bitten too many times on the APIs.
Well, we do still have it, and if you want to dig in and configure things that DNAC isn't automating for you, you can certainly do it, and you can do it by the API in DNA Center.
But will the API have 100% coverage of commands? Because traditionally,
We are getting better every day, and I will honestly say
so that's
that.
a no.
We are.
So just so I'm
100%
clear,
coverage, I can't say we.
I'm saying that should be something you strive for. They should be equivalent.
Agree.
Otherwise, what's the point? It drives me crazy when I try and automate something and I get 6 steps in, and the 7th step I have to go back to using a CLI or even a netconf do it via the CLI command. It drives me nuts.
My guess is that's why it's using the access mechanism that it's using.
No.
Right. Captain Obvious hat.
Someone's
Can I
got to
just
have
ask one question?
Sure.
I've never used DNA Center, so I'm just going to play the dumb whatever. I've never used it.
one. You
But
get to using it soon.
is DNA Center, speaking of APIs, can I just tap in DNA Center and do my thing?
Yep.
Okay. I thought that's
can.
what
Of
I was
course.
hearing. So
Can you go over a little bit of what's automation versus someone clicking some buttons and send these commands out within DNA?
It's essentially all automation. I mean, we do have a command runner, and we can then log into the CLI via DNA Center and do some show commands. We do have the API where we're able to, do Conft and do all those. We have a couple different tools we can do that. But then DNA Center, everything that you're configuring through DNA Center. So when you're assigning a certain role in the fabric, you're defining your services, so your DHCP, your AAA, NetFlow, and you're saving that configuration, all that gets pushed and automated to DNAC. Does that answer your
I
question?
was just curious if devices were either checking in or DNA was proactively doing some of these best practice rollouts, or
So it's when you save it. So you define your network settings for a site. When you assign the devices to that site, they get all those settings, which means they get all that associated configuration. So you see NetFlow, that means all the NetFlow monitor exporter configuration gets applied.
So it's more templating than automation at that point? Like you're basically defining a template and saying, if it's this sort of device and it's in this location, this is the config that's going to get pushed when I put that device into
Specifically for the network settings, yes, because those network settings are going to be applicable to site. So you may have a DNS server, a DHCP server, a AAA server that's specific to your California location, but you might have a different set of those for your Washington location. So then you create these different sites and you're applying that configuration, associating that configuration to a site. That's for the network settings. Now, when we're talking about fabric, creating fabric, it's specific to the type of node it is, right? So what's the functionality that device is going to have? Is it going to be a control plane node, a border node? Is it going to have L3 handoff? We also do host onboarding. So this is around AAA configuration that's at the port level, which I don't know if you guys have done that, but that sucks to configure, right? It's a lot of configuration. It's applied to every access ports a lot. So I know I have very little time. Let me just finish this up. So we have, this is again our border. So I've selected what virtual networks or VRFs that I want to have configured and pushed and leaked out to the firewall or to the Fusion router. So this translates into an SVI, right? So every single one of the virtual networks that I choose to leak ends up getting configured on the border, my external interface, as an SVI with the /30 subnet. And the infra VN, that needs to be selected, and that's what actually establishes the BGP neighborship. So all this configuration gets applied to my external interface at the border, and then all you need to do on the other side, again, yes, it's manual today, is basically copy that configuration and swap out an IP, right? You click save, and save here, and then that configuration gets applied. And again, I had mentioned you can go into Command Runner, do some show commands, see what has been configured. You could do show history, see what DNAC specifically configured over a period of time. But what this does is really helps you to automate all that configuration. You don't need to understand it. You don't need to know it.
Would you say that that's the primary problem that we're trying to solve, is to abstract away a lot of the complexity, which is a common...
Specifically for automation.
Yeah.
Right. Yeah, fat fingering, inconsistent.
The time it takes to get
I see this as
devices.
cost of ownership.
Cost
This
of
reduces
ownership?
the cost
Okay.
of ownership. At the end of the day, it all comes down to reducing the cost of ownership. Instead of employing a CCIE and 2 or 3 CCNPs and then spending days working on the configurations that you're going to rush out and deploy, you're going to click a button here and it's going to be done.
And that's the baseline. The result is the
Yep.
cost of ownership decreases because
Yep.
you don't have to manually configure all the devices.
Yeah, there's a
Just the
lot of
standard.
operational costs. Plus,
Yeah.
not only maintaining this and monitoring this, but then you have an issue because say the configuration was incorrect. How do you troubleshoot that? So our assurance piece gives that visibility. This is what configuration it has. This is what's going on. This is how many devices it's affecting. This is how many endpoints and users it's affecting. And this is why.
Yeah.
And do you want to go fix it? I can go fix it myself or let DNA Center fix it. And that's a big thing that we don't have today. Sure, we have Splunk, sure, we have all these different monitoring tools, but we have something that says, hey, there's an issue. Okay,
Yep.
well, where's the context? Where's the connection of where that issue, what that issue is, how that issue happened, what it's affecting, and how to fix it? We don't have that.
Yeah.
And with assurance, we're able to pull all this context from all of our devices. We're able to pull it from ICE. We're able to pull it from AD, from all these different things. And that gives you this visibility of saying, look at this issue. This is what it is. This is why. This is when. This is how. Fix it.
This is where the CIO says, I hate my network. He hates his network because you did all this manually. If you had this and this works, it's going to be a while.
And you could do it with your eyes closed.
I applaud Cisco for moving in the direction of having a more programmable, programmatic infrastructure, whatever term you would like to use. That's very, very important, and that's where we're all going. I still wonder, though, because we've been throwing around the intent-based networking term quite a bit. I still wonder if we're actually doing intent-based networking.
So think about it.
Which we haven't really addressed in depth.
Intent, true. And that's around policy.
Yeah.
Right? Who's on my network, what's on my network, and what I want them to access. Now, through dynamic authentication, you define that, and you get that, right? I can say whether you have this certain operating system, you have this certain posture status, you're in this certain location, you are a guest user, it's between 8 and 5. There's a lot of different attributes we can assign to it that then determines what access they get, right? So the dynamic authentication using ICE and then using TrustSec to apply those SGTs, which is kind of this unique identifier that says, now you have access to X, Y, and Z, we can do that. And so if my intent is my guest users only have access to the internet, then I just define a policy that whenever they come on the network and they go through the guest flow, they get guest access or what have you. So that's kind of around intent.
But to be fair, we're always configuring intent when we sit at a command line and configure what we want, right? And so how would you address the idea that we're not, because you're talking about the intent as in, I want my users to be able to log in between these hours, but you're not necessarily addressing the entire overall business intent and abstracting away the configuration in that sense. You know what I mean? Does that make sense?
Sure. But when you look at, so I was talking specifically at group-based policies.
Okay.
So our higher level is segmentation, right?
Yeah.
And so that's another type of intent, right? I want these users to be completely separated from these users, right? And I want these users to have a completely different fabric, being within a different fabric domain as these users. So that's also kind of around intent. And also, when we're looking at intent around assurance, what type of performance should they get? What the onboarding time should be, and the things of that nature is around kind of intent.
I have a question regarding the ICE implementation. Is this also part of your story? So if changes are needed in the ICE side of things, will this also come from here, or this is also?
It is. So ICE is part of the solution. ICE is responsible for authenticating and authorizing the endpoints, users, and things onto the network. And it is responsible for, you configure your policies in DNAC, it gets pushed to ICE. ICE communicates to all your network devices, so your edge devices, your borders, and says these are the source SGTs, and this is the SGACL to apply. So ICE is responsible for that.
My question is more regarding to, you just expect that ICE is there and is working, or is this integrated and you can check also that this is all working?
It is integrated. So ICE is actually looked at from our assurance piece. So we have visibility into how ICE health is and such. And we also have integration where we're configuring through DNA Center, we're configuring components on ICE itself.
Okay.
Yeah. So I need to wrap up, but the gist of this is that we have a lot of different firewalls today. We have a lot of firewalls to maintain. We have a lot of segmentation, a lot of policy. It's a lot of work in our traditional networks. With SD Access, we can minimize that significantly by, as we all know, automating a lot of this configuration. And we don't need all those different firewalls. We don't need them placed all around. We can have them simply in various locations, and we can manage it that way. Well, thank you very much.
Thank you.
Thank you.
Thank you.